factor, which allows you to convert from either a mass unit such as grams into a volume unit such as milliliters, or given a volume unit such as milliliters, convert into grams. Typically, the way you see density written is how we have it here on the screen. 1.264 grams of the glycerol per milliliter. But using dimensional analysis, you are allowed to flip this conversion factor or this ratio so that you can solve for either the mass or the volume units. Let's take a look at this example. What is the mass of 50.0 milliliters of glycerol given the density of glycerol 1.264 grams per mil? In this case, we're going to start off with a volume unit and multiply by the density as written, the 1.264 grams per milliliter. And if we fill in the 50 milliliters here, so 50.0 milliliters, write that over 1, multiply that by the density as written, the 1.264 grams per milliliter. Using dimensional analysis, we see that the milliliters are going to cancel, and it leaves us with only the grams in the numerator. Doing the math across the numerator, I get 63.2 grams. The only unit left in the numerator being grams. So again, starting with a volume unit, use the density as written, allow the milliliters to cancel, and you will get your mass units. Let's take a look at another example. That's a little hard one. Let's try this one. What is the volume of 1.2 kilograms of gold, which has a density of 19.3 grams per mil? In this case, your starting unit is a mass unit. So you're going to start with mass, and now you're going to use the density as a conversion factor, but this time you're asked to solve for a volume unit, so you're going to flip it so that the 19.3 grams is on the denominator and the milliliters is in the numerator. That will allow the mass units to cancel, and you will solve for your volume unit, in this case, milliliters. So we're starting off with a mass of 1.2 kilograms of gold. We're going to convert that into grams, understanding that there are 1,000 grams per 1 kilogram. That will allow kilograms to cancel out. And now I'm going to use my density as a conversion factor. The milliliters are in the numerator. The mass of 19.3 grams is in the denominator. And grams cancel. When I do the math across the numerator, 1.2 times 1,000, I'll divide then by 19.3. And to two significant figures, I get 62 milliliters. So that is the volume that is containing that 1.2 kilograms of gold. Let's try a little bit more complex problem. In this problem, I want to determine the thickness of a 5.79 milligram sheet of gold that has an area of 44.6 square centimeters. And I'm given that the density of gold is 19.3 grams per cubic centimeter. Recall that 1 milliliter is exactly equal to 1 cubic centimeter. Sometimes that is important. So in this case, I want to use the density to find the volume, because I recall that volume is equal to length times width times height. That will give me volume. I also remember that area is equal to length times width. And if we look at the problem, we are given that we have 44.6 centimeters squared, and that's the area. So that tells me I already have this component here, which is going to be 44.6 centimeters squared. What I need to solve for is the height and the volume. Now I can get the volume using the density as a conversion factor, because I'm told that I have a mass unit of 5.79 milligrams of the gold. So I'm going to convert that into grams. I know that 1 gram has 1,000 milligrams. That will cancel the milligram units. And now I can use the density of the gold, the 19.3 grams per cubic centimeter, as a conversion factor. The cubic centimeters are going to go in the numerator, and the 19.3 grams in the denominator. Grams will cancel. The only unit left in the numerator is my volume unit, which I need for up here. And doing the math, I got 3.00 times 10 to the negative 4 centimeters cubed. And that is the volume that I'm going to plug into the above expression. So going back to the fact that volume is equal to length times width times height, I now have this equation. 3.00 times 10 to the negative 4 centimeters cubed is equal to length times width times height. Recall from the top of the problem that the length times the width is the area, and the area of this is 44.6 centimeters squared, and that's going to be times the height or the thickness. So now I'm going to divide both sides of this expression by 44.6 centimeters squared, and that will solve for the height or the thickness. So over here we're going to solve for h, and when I do my division here, my answer that I got is 6.73 times 10 to the negative 6 centimeters, because the centimeters squared cancels here, centimeters cubed cancel, leaving us with the centimeters in the numerator. And that is the height or the thickness of this piece of gold. It is 3 sig figs because we were given the fact that we had 5.79 milligrams of the starting material, and they also gave us 3 sig figs here. So the entire problem was working with 3 sig figs. 3 sig figs here, 3 sig figs here, and down here, 3 sig figs divided by 3 sig figs gives us the 6.73 times 10 to the negative 6. So I hope this example was helpful to you, and I look forward to hearing from you again. Good night.